If you heard your algebra teacher say this polynomial is prime, what does she mean and how does she know when it's prime, when it's not prime? So in this video, we'll look at two examples, and one of them is going to be a prime polynomial and one is not. So let's check them out. Now here it's a little bit more complicated because we actually have two variables. We have p and q, but it's the same idea. So we're just going to put p, q in each factor. And then what we do is we're going to look for two numbers that would multiply to -6 and that would add to -5. All right. Now, because they multiply to a negative, one of them has to be positive and one has to be negative. We'll start with -6 and, oops, over here on the calculator and divide it by -1. Then once we get an integer, which we do, we're just going to add them up and see, is that equal to that middle number? Well, no, it's actually equal to 5, not -5. So at this point, you could maybe guess that what we were supposed to do is divide by -6. But let's just say that if you're not guessing, you just go start with -1, then -2, okay, add them up, -2 plus 3, that's 1, that doesn't work, okay, how about -3? Well, that's 2. When we add them up, that again doesn't work. What about -4? That is not going to even be an integer, so that we should not be considering that. And this is also a decimal. But if we use -6, and now we add them up, we actually get the middle number. So now the answers are -6 and +1. So let's write that down. -6q plus 1q, which we don't have to write 1. Now, I always recommend checking your answer by foiling. So first, that would be p squared. Then it's going to be outer, so p times q. Then inner, right? So that would be this one. That would be -6pq or qp, doesn't matter. And then finally, it's going to be last, which is going to be -6q squared. Okay, so if we look over here, this is like pq minus 6pq. And that's the same thing as saying 1 minus 6 is -5pq. So that works, which means that this polynomial is not prime because we factored it. We were able to factor it and we were able to check our answer by foiling. Now, let's look at the second example. Now, here, though, this is going to be more complicated, okay, because we might have to check a lot of stuff. Well, let's see. Well, maybe not. Oh, okay. So we got that 11. Okay. So this is where the problem starts. When you look at 11, okay, which numbers can multiply to 11? There's not that many options. And if they have to multiply to positive 11, but the sum is negative, that means that they both need to be negative. And the only two negative numbers that would multiply to 11 would be like -11 and -1. But if you add them, you're not going to get -5. Nothing else works here, right? There's nothing else. And so that means that this polynomial is prime because, again, you can try it, you can start multiplying, but you always have a decimal because, by the way, 11 is a prime number. So no matter what you do, you're not going to get an integer unless it's like 11. But again, it's either -11 plus 1, that's 10, or -10. That doesn't work. That's not equal to -5. So we were not able to factor this one using integer coefficients. And that's when a polynomial is called prime. So in this case, we're just going to put D, N, E for does not exist.